In section 3.2c, we're going to take regression lines next level, where we're going to talk about standard deviation and we're going to talk about R squared as well. So you remember back in chapter 2 when we did standard deviation, it was the typical distance a data point was from the mean. So standard deviation of the residuals is to assess how well the line fits the data. We have to consider the residuals for each observation, not just one. Using these residuals, we can estimate the typical prediction error when using the least squares regression line. So here's the formula for S, but as you know, you're going to either probably be given S or you will be able to find it in your calculator. So this value gives the approximate size of a typical prediction error, or typical size of the residual. We also have the coefficient of determination. While the standard deviation of residuals gives us a numerical estimate of the average size of our prediction errors, there's another numerical quantity that tells us how well the least squares regression line predicts values of the response y, and that's R squared. Again, look at this formula. I'm not going to make you understand this or use it. You'll use R squared from our calculator like we already say. So R squared tells us how much better the least squares regression line, LSRL, least squares regression line, does at predicting values of y than simply guessing the mean y for each value in the data set. So basically standard deviation and the least squares regression line tells us ways to tell how well our line is or how good our data is. From our book, you might want to follow along with this. There's some good information here, and there's another example in our notes. But it says in 3.1, we looked at the relationship between the average number of points scored per game X and the number of wins Y for 12 college football teams in the SEC. A scatter plot with the least squares regression line and a residual plot are shown. So they give us Y hat, which remember is the predicted value, and they also tell us S, which is 1.24, and R squared, which was 0.88. Notice our residual plot, there's no pattern, so that means that a linear model is reasonable. So, part A, calculate and interpret the residual for South Carolina, which scored 30.1 points per game and had 11 wins. So if you take the predicted amount of wins for South Carolina, we would take our Y hat equation and we would substitute 30.1 in for X, the points per game, and we get 9.40 wins. That's our predicted number of wins for South Carolina. So the residual for South Carolina is the observed value minus the predicted value, 11 minus 9.4, which is 1.60 wins. So what does that mean? That means that South Carolina won 1.60 more games than expected based on the number of points. Letter B says, is a linear model appropriate for these data? Explain. And I already talked about this. Our residual plot looked good. If we look at our residual plot, there's no pattern to these points. So because there's no obvious pattern left over in the residual plot, the linear model is appropriate. Letter C says, interpret the value of S equal 1.24. Okay, I'm going to give you something standard to use for this here on the next slide. But for right now, this basic model is what we're going to do. So to interpret S, when using the least squares regression line with X equal to points per game to predict Y, the number of wins, we will typically be off by about 1.24 wins. This statement is what you're going to do for every problem when I ask you to interpret the values of S. So you're going to start with this and you're going to fill in with your X here and you're going to fill in with your y here. And then this 1.24 is your s. So this statement is what you're going to write every time that I ask you to interpret s. We have a similar statement for when we interpret the value of r squared. R squared is basically telling you the percent by which your variation is. So this is 88%. So about 88% of the variation in wins is accounted for by a linear model relating wins to points per game. Y. Add this to your notes. When I ask you to interpret S, you're going to say, when using the least squares regression line with x equals blank, you're going to fill in the blank with whatever x is, to predict y, fill in the blank with whatever y stands for, we will typically be off by about s, whatever the standard deviation is. When I ask you to interpret r squared, you're going to put r squared here as a percent. So remember 0.88 was 88% of the variation. You're going to put the y variable here, is accounted for by the linear model relating the y variable to the x variable. So you're going to, this is something you're going to want to make a flashcard on, because this is what you're going to want to say when I ask you to interpret s or to interpret r squared.